Today, we're going to take a look into independent events. Now, the main idea here is that with the probability that one event occurs in no way affects the probability of another event occurring, we're going to say that those two events are independent events. The idea here is that you might have one event after the other. If the first event does not affect the occurrence of the second event, then we're going to claim that the two events are independent from each other because they're not affecting one to another. It's better we just show some examples. So let's start. Well, first, we want to see if the following are examples of independent events. And then we want to find the probability for those scenarios. So let's take one example at a time here. Now, if we look at example A, it says that we're going to have a jar which contains 3 red balls, or what are they, marbles, 3 red marbles, 5 green marbles, 2 blue, and 6 yellow. Now it says that a marble is chosen at random from the jar. After replacing it, a second marble is chosen. The question is, what is the probability of choosing a green and then a yellow marble? Okay, so let's picture the scenario here. So you have a jar here. Well, imagine that that's a jar. And on it, we got different marbles. We have 3 red. We have 5 green. What else do we have? We have 2 blues. And we have 6 yellow, not red, yellow. So we have 1, 2, 3, 4, 5, 6. All right, so we have a jar, and then we have this. Now it says we want to choose a marble at random. So we choose a marble at random, and then we're going to replace it, and then we're going to choose a second marble. So let's look at what happens the first time that you choose something at random. It says, what is the probability of choosing a green and then a yellow marble? So let's take a look into the scenario where we choose a green marble. If we want to find the possibility or the probability for us to choose a green marble, this is just notation. It says the probability for us to choose a green marble, it's always going to be how many of that group there are, which in this case there's 1, 2, 3, 4. There's 5 green marbles, and we're always going to divide it by the total amount of options that we have. So how many marbles do we have to choose from? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and that is 16. So if we want to find the probability, we're just going to divide this. So we're going to have 5 divided by 16. So that means that the probability for us to choose a green marble is of 0.3125, but that's a decimal representation. We actually want the probability, so we're going to multiply it by 100. So that means that there is a 31.25% chance for us to choose a green marble. So in our first try, there's a 31.25% chance that we choose a green marble. So now, what is the probability for us to choose a yellow marble later on? Well, let's see here. If we're going to be choosing a yellow marble, so the probability for us to choose a yellow marble is going to be, well, we're going to see how many yellow marbles do we have. So we have 1, 2, 3, 4, 5. We have 6 yellow marbles. Now, how many different options of marbles do we have? If we count them again, we're going to have 16. So the probability for us to choose a yellow marble It's going to be 6 divided by 16, which is going to have a 0.375, but we want an actual percentage, so we're going to multiply that by 100. So that means that we have a 37.5% for us to choose a yellow marble. Now, to see if the first event had any effect on the second event, well, let's look at example B. And then after example B, we can compare example A and example B, and then we can see which of those two can be classified as an independent event. So now notice that in example B, we still have the same marbles. We got 3 red marbles, we got 5 green, we got 2 blue, and 6 yellow. But notice that here, the scenario, it's a little bit different. It says, you choose a marble at random. Okay, so let's do our jar here. And we're still going to get the same amount of marbles. We got 3 red. Well, let me just finish that jar here. We still have the same. We got 3 reds. And then we have 5 greens. And then we have 2 blues. And then we have 6 yellows. So 1, 2, 3, 4, 5, 6. All right, perfect. But notice that here, there's a slight difference as to how the scenario plays out. So notice that it says a marble is chosen at random from the jar. All right, cool. So we're first going to choose a marble, and then we're not going to replace the marble. So you choose the first marble, you take it out, and you're not going to replace it just like we did with the first example here. And after you do not replace it, you take a second marble out. Now let's see what are the probability for the same events here. So what is the probability for us to choose a green one? Well, if green is the first marble that we choose, let's see, what is the probability for us to choose a green marble? Well, how many green marbles are there? So there's 1, 2, 3, 4, 5. There's 5 marbles, and we have 6 to choose from. And if we look from the top, we found out to be 31.25%. Now, what is the probability for us to choose a yellow marble? Well, here it's what it's different, because we choose a green marble and we don't replace it. So now we don't have 16 marbles to choose from on our second try or on the second chance of choosing marbles. We don't have 16 anymore, but we got 15 because we took one out and we did not replace it. So now notice how the probability of choosing a yellow marble is going to change, because now the probability of choosing a yellow marble, there's still 6 yellow marbles to choose from, but there are not 16 choices anymore because you took one out and you took it out. Now you don't have 16 anymore, but now you have 15. So now if we do not replace the marbles, our new probability for Y, which is the yellow marbles, it's going to be 6 divided by 15, which is 0.4. And if we want the actual percentage, that's 40%. So let's actually pause here and let's think about what just happened here, because we still need to determine if this is an example of a dependent or independent event. So if we look at example A, we first choose a green marble and we replace it. And then after that, we chose a yellow marble. So notice here, the first event, which is us choosing a green marble, did not have any effect on the second marble because we didn't change the number of choices that we had at the end. But if we look at example B, it's a little bit different here, because now you initially had 16 marbles. So you choose a green one and you did not replace it. So now notice that the first event, which it was you choosing the green marble, had an effect on the second event because you choose one out, you took it out. So when you try to find the probability for the yellow marble, you're working with different numbers because now you don't have 16 choices to choose from. Now you have 15. So in this case, the first example, or example A, this is an example of independent events. Because the first event did not have any effect on the second. But example B, this is an example of not independent. Let's look at example C now. It says, so we're going to toss a coin and it comes as heads. What is the probability that the next toss will be heads as well? Well, let's say you flip your coin once. So what is the probability for you to choose heads? Well, that's 1/2, which is 50%, because in any coin, you're always going to have 50% to choose heads or tails. So this is the first event. And then it says, well, what is the probability for for your next toss to be heads as well? Well, we have not changed the coin. We're still talking about the same probability because we have not changed the coin. We're looking at the same scenario. Nothing has been replaced. So the probability for you to be choosing heads again is still 1/2, which is 50%. So notice that, so this is the first event. And this is the second event. So notice that the first event did not have any effect on the probability for the second event. So example C is another example of an independent event. Let's take a look into one more example here. Example D. So now let's see what we have here. Look at the scenario. So it says you have a jar that contains 3 pennies, 2 nickels, and 5 quarters. What is the probability for you to pick a nickel from a jar? Then without replacement, what is the probability for you to be choosing a quarter after that? Okay, so let's take a look here real quick. So let's draw our jar here. And let's say you have 3 pennies, which I'm going to do them in red. So 1, 2, 3, you have 3 pennies right there. Let me just make this a little bit larger and easier. So we got 3 pennies. And we also have 2 nickels. And we also have 5 quarters. So that's 1, 2, 3, 4, 5. All right, let's see. Let's look at how this affects our events here. So let's look at the first probability, because it says, what is the probability for you to pick a nickel from the jar? Okay, so here, this is what we have for nickel. So the probability for us to be choosing a nickel, it's going to be, how many nickels do we have in this jar? Well, we have 2 nickels to choose from. And now, how many different options of coins do we have in total to choose from? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. So the probability for us to be choosing a nickel is going to be 2 divided by 12, which is equal to 0.166, which we want the percentage, so we multiply by 100. So this means that we have a 16.6% chance for us to be choosing a nickel. Now notice that we chose a nickel, which is good. We already chose it. So we already have this event. Now, after we choose that nickel, we don't replace it. So let's say that this nickel here is no more. So now, after you choose a nickel and you did not replace it, now you want to find out what is a possibility for you to be choosing a quarter. Well, let's see. The probability for us to be choosing a quarter is going to be, well, how many quarters there is for us to choose from. So that there are 5 different options. Those are the 5 different quarters that we have. But now, how many jars there are? How many marbles, or what are these coins? How many coins there are in the jar? Well, we don't have 12 anymore, but because we took one out and we did not replace it, now we have 11. So let's find out what is the probability of that. So 5 divided by 11. This is equal to 0.45. And if we want to know the probability for that, we're going to multiply by 100. So this means that we have a 45.45% to be choosing a quarter. So now notice that the first event did have an effect on the second event. Because you did not replace it, you're affecting the different choices that you have for the second event. So this is an example of not independent. So now, here's your entrance ticket.